Good morning, guys. Today's lesson is 6.03, Introduction to Frequency Tables, and today's aim is how could we interpret data from a table. So you're due now. Using the two-way frequency table below, what do you think the original question was? So the original question was, if you could have a new vehicle, would you want a sport utility vehicle or a sports car? And they are asking both men and women. How did I figure that out? Well, I figured it out based on the columns. So I saw male and female, so I knew they were asking people something, and then I saw SUV or sports car. Okay, so what is a two-way frequency table? You guys probably know it from algebra, but it's a visual representation of a possible relationship between two sets of categorical data. Keywords there, right, is two sets. So in this do now, we were comparing male, female versus types of car. So it was person by gender, types of car. So breaking down the table, right? The outside entries within the table are joint frequencies. Why? Because they are representing two things, right? So this column, the 21, represents males who prefer sport utility vehicle, sports car, or males who like sports car, right? The outside frequencies are called marginal. So these are things like adding that across the columns or adding down, I'm sorry, across the rows or adding down the columns. And these represent like totals. So this 156 here represents the total number of people who prefer SUVs. This 60 here represents the 60 total males in the survey. So to find the whole table relative frequencies, we take the total count, which is at bottom right, the 240 total, and divide each value in the box. So like, in other words, if you're trying to find probabilities, this is how we would do it. We would divide each total by the total. So everything divided by 240. To find the relative frequencies for each row, we take the marginal frequency, the outside, and divide it by the inside. So if we wanted to find out, right, the number of males who preferred SUVs, right, we take the number of males total, which is 60, divided by, and divide 21 by that. 21 being the number of males who preferred SUVs from the original. And the same would be true if we were trying to find the relative frequencies for each column. So we were divided the 156, right, which is the total people who preferred SUVs, and do 21 divided by 156. That tells you the number of males who preferred SUVs. We're going to get more into this tomorrow, and we're going to do it a little bit or tied into what's been going on around the country lately. So we could use the frequency tables though for two things. We can get total counts, right? Frequencies or tallies. And we could also use it to get probabilities or relative frequencies. So either one are possible. You can get probabilities from numbers, you can get actual values from probabilities or actual counts from probabilities. All right, so guided practice. You have this table here, partially filled. You have these three questions, answer them, and come back and review. All right, so first, how many total wins did the girls' teams have? So total girls wins is going to be here, down the column. So all I did was add the column together. So I got 53 total wins. How many more wins did the boys' team have than girls? So we already have the total from the girls, right? We just added down. Now we're going to do the same thing for the boys. So we add down the column. That gives us 78 total wins from the boys' team. The difference between them is 78 minus 53, so 25 more wins. Last question, what percent of total soccer team wins were from the girls' team? So let's look here, right? So first we need to figure out how many wins the soccer team had total. So we add across this row. We get 40. We then take the number of girls soccer wins, 25, divide it by 40 to get 62.5%. That's the total percent of girls wins for soccer. All right, so independent work. You have these two questions. This was pulled from a Delta Math question. Complete them. I will post the correct answers on Wednesday. Have a great day, guys.